How's it going, everyone? Welcome to another video on front-end system design, which is a course taught by Yvonne Reid, software engineer that previously worked at JetBrains for over 3 years, and now he's currently at Meta. And the goal of this course, and in today's video, something I'm going to explain that. But first, the goal is to look at how, as a UI specialist, what are the fundamentals that we need to learn as a way to now solve common UI problems, like how you can now create scalable web applications, okay? And what are the things that we need to know as a way to achieve that. So in today's video, we're gonna take a look at the browser, or specifically is as the web API for complex UI patterns. So why is this? How do we get here? Let's make a quick recap of that. Where now we have is as a way to understand now how to make that happen, how to now build these web apps or all of these UI web apps in a scalable way. We need to know is first, what is an application? So what is this system and what is the goal of this system? So an application is a way of how you can now provide something that you can apply, that you can use that, and that is made of, well, 3 layers. You have now, broadly speaking, you have now the backend, the API, and the frontend. Because in this course we take care is more about is the frontend, okay? That's what we're gonna talk about. So this frontend component has several areas that we need to understand because they are part of this application. So you have now how this application communicate, okay? What is the protocol that you want to use as a way to communicate? Also is what is the what is the way of how, once you get that data from the server, from the API, how you're going to manage that data, as well as the how you're going to store and manage your data, data management, and then how you're going to create now UI patterns or build this UI to cover more complex user case or use cases. So you have now is the UI, for example, UI web, or like this. So web API for complex UI patterns, which is common things that happens over and over and over. And instead of actually doing some hacky stuff, we actually see what are now the things that the browser and also the spec developers actually create as a way to solve these specific problems and provide these APIs. That's what we're going to talk about that. And the other is this: how can we now manage all of these assets? So the HTML, CSS, and JavaScript. So the TLDR of this is that we're going to talk about first the core fundamental briefly, and then about the DOM API and how now that would allow us to build is this complex UI patterns. So first thing first, you need to understand that the core fundamentals, that is especially how the browser now treats HTML elements, and as a way to provide now styles to this, by using is or by understanding is the box model. So what is the box model, and what is the box anatomy? What is the box property, like size, whether it is restrict or intrinsic, or the type of boxes. You have now block, inline, and anonymous, and how, for example, the block and inline, each one of them follow a specific rules that they participate in something called the formatting context. This formatting context there are certain rules that applies to these elements, this box, and they have now a way of how they can behave there. So for example, like block and inline. The whole point of this is to see how now this formatting context, where the key feature of that is that not only is isolating all of these elements inside of this context, formatting context, but also it is scalable. Why? Because if the spec developers, let's say they want to create a particularly different layout system, so instead of putting elements like a block or an inline or a flex or a grid, they decide to create some other formatting context or way of how you can now organize your elements on the screen. You can do that. So it makes that scalable and also predictable, because each one of those formatting contexts follow that particular rules. So once you know that, as a way to know how the browser lay out all of its components, and then how the browser now put all of these elements on the UI, which is using is the browser position system. That is the normal flow. So from putting elements from left to right and then top to bottom. And when you change now the way you tell the browser how you put your elements, by using, for example, position relative or position absolute, or CSS transformation, each one of those create now something called as a stacking context that has a particular rules applied to that. So this is stacking context, which is whether it's when you create a position relative. So you're taking that now layer of elements out of the normal flow, or you're using is absolute for that. We're using CSS transformation. So this is stacking context is something that we can use as a way to now improve the performance of each one of this layer, the stacking context. So why do we want to improve the layer of that? Because we want us to improve the user experience, and for that, so we want is to now is use some of this hardware accelerations property that come from the CSS to prevent reflow. What is reflow? Well, because it's one of the face of how now the browser transforms your HTML, CSS, and JavaScript into pixel on the screen. It belongs to this assembly line, alright, where initially, once the browser receives the HTML, CSS, and JavaScript, it say, hey, I get this. Let me transform that into something that I can now work with, which is the DOM, this digital representation of this document, similar to this digital representation of the CSS object model. And then you're going to merge that using the render tree, which is now contains all of these informations in a tree-like data structure. Tree-like data structure, I'm not going to dive into that. I'm not going to get into the weeds of that. But the thing here is that this is the way how you can represent, how you can tell a computer that this is the way of how you want to organize data, that this is the way of how you want to now represent things in the real world, so you can now work with that. So this is the render tree, and then because now this render tree contains all the necessary information, but it doesn't know when it's going to put that on the screen, that's what we have is the reflow. So reflow is this step that calculates the position and the geometry of the elements on the screen. So this is usually triggered with CSS, with JavaScript, sorry, when you modify is the geometry or the position of these elements. And what happened is that it trigger is now an unoptimized pipeline. What does it mean? Well, if you do that, you change the geometry or the position of that, the browser now is going to use a GPU part of the layout as a way to calculate the layout phase to, well, do what it has to do. But also we can use this now is the other optimize pipeline, which is the paint and compose. By using just is this particular CSS class, which is transform, we are not only tell is, hey, instead of actually you use the CPU, let's going to now use this the GPU for this set of elements as a way to now render that. So how this process work, how now the browser is creating is all of this composite, how the browser is composing this layer. Because older browsers only use CPU, now modern browsers can have a combination of this, CPU and GPU. And the way that it works is by, well, the browser initially creates the render tree, which is matched one-on-one with all of these DOM elements. But because that's something that is not efficient, when we are creating is this stacking context or elements that is outside of the normal flow, we create now a render layer, right? These render layers will be created anytime we use, for example, position relative and absolute as well as transform. Okay, so this is now a way of how you can, the browser is closer to the GPU. However, because still this is not something that is optimized, okay? Because as long as you use this one thing, you are creating is essentially is this render layer. There is something called the graphic layer. So this particular layer is actually talking directly to the GPU via 3D or perspective transform. The render layer has 3D or perspective transform properties. Layer is used. Oh, interesting. Layer is used by video and canvas. So anytime you tell the browser to use a video and a canvas, behind the scenes now through the composite layer is actually talking directly to the GPU. And also when you use this now 3D or perspective transform. So that's quite interesting because all of these fundamentals, all right, is just as a way to see, all right, so now that we know how these things work behind the scenes, how can we actually build our own UI? That's what we need to take a look at the DOM API, which is this document representation of the DOM in a tree-like data structure that contains a set of properties and methods that we can work with. And this is useful, for example, if you wanted to build something, let's say a portfolio with a minimal blueprint apps as one of them. The other is that, hey, what if you want is to now build in some low-level libraries as a way to say, hey, DOM management, like what is doing React and Angular and Vue. Hey, DOM management and virtualization, how you can build that? Well, this is the use case for that. Again, they are now having is this particularly a problems here, right? Or they now facing that particularly challenge here. And the other is that when you want to create is a component when you want to create a component, let's say a video or a chart engine that is using SVG elements, for example. So because of that, we need to look at first is, well, because the DOM is not exclusively to be accessed by the JavaScript, you can also use Python for that. In our case, because we're using JavaScript, we want is to actually is Yeah, we want is to actually is the we want is to actually is use the global objects. That's one of them. To take a look at what are the object that we can have access to, which is the window, the document, and the body and the head, as well as what is the structure of the DOM, right? So it all starts with the node, which is this DOM representation of the tree-like structure. The node that the element can extend from the node this abstract base class, where now on the element we have now is this base class that where now is pointing to the DOM, where now we can derive other elements, for example, like HTML elements or SVG elements or any XML other element there, right? And then now the DOM, the node, right? It also extends from, or text node have access to this property of the node. What you want to now create is a node text with content text, all right? And also the HTML document, which is something that I don't know why they have that wired to that. I think this is for legacy purpose. And then you have now the window, which is something that is contained on the HTML document. So then we look at what are the most common operations that we can do. So get element by ID is actually is the most performance of all of that. Read time and read costs are actually 0.1 because it's pretty much like reading a property on a hash, right? Then you have now get element by class name and tag, and here is you say, all right, because now the element that this return is a HTML collection, which is a legacy collection. That is now live, which is a live collection that you have access to, and the way to access to these elements is using the depth first search in order. Depth first search in order plus a hash map. So anytime you actually the first time you want to, based on your selector, find elements here, it will now have that and store it into a hash, in this sort of catch. So subsequent query to that, it'll actually get that blazing fast. One of the downside of this is because this is a live collections. If you are changing the geometry or the position of these elements, it's gonna trigger is reflow. All right. Unlike, for example, query selectors or query selector all, what the query selector is like, well, it's actually a traverse that tree in a PF. It traverses that tree in a using is a DFS, all right. And instead of returning is the live collection, it gives you now an element for that, which is a copy based on these selectors. Similar to the query selector all, is going to return you now a copy of that, which is a node list. So the trade-off of this is, even though that this might be more memory intense, when you're using query selector, it's going to depend on the browser implementations. Query selector, or a lot of the time, is quite decent the performance, and it is also more recommended to use query selectors than get element by class name or by tag name, especially if you need to after that iterate through that collections. So one of the best practice of this is that use small selectors and IDs when it comes to act as an entry point, as a starting point where you can now get these elements and operate on that. So we also look at other methods like adding and removing. So pretty much inner HTML and insert adjacent HTML are worse. That is the worst. Both of them are bad, right? But inner HTML is worse because it's not have to parse that. Unlike is the append child or insert adjacent elements to that, because you already contain that element, so there is no need to actually parse that. And then remove elements like that. And then we look at a particular example of how now can we actually without triggering too much reflow, only when we append the element, is to create that with all of the tools that we have learned so far. For example, like query selectors. All right, this is actually the code that we use here. Okay, so see how now by using is the query selector, all we get now, we passes the selector, the specific selector for that, as a way to now get that element and then populate that. So that element is now a node. Okay, so this query selector all return is a node list that you can now have modify this content or provide some content, and then you're gonna call that. That was a very simple exercise as a way to build is this simple UI element, right? But when it comes to actually handle this more complex patterns, right? To cover more business use cases, all right? So when it comes to do, you got it, okay. All right. Yeah. So when it comes to solve some of the most common UI patterns, yeah, when it comes to build some of the most common patterns, back then we got a lot of hacky things to do. That's why spec developers create this observer API to solve specific problems. Okay. Where unlike an event-based API, this actually have three classes for each one of those specific problems, or for each one of those specific use cases. So for example, we have now the intersection. Okay, we got now the intersection for that, right? This is now called the observer API. Okay, observer API. That's quite interesting, by the way. It's like the observer API. There you got it. No, but this is the intersection observer. No. Mhm. Mm. Mm-mm-mm. Is the observer appearance like this? Um, Pattern? But is the observer pattern? Exactly, it's the observer here. That's what I wanted to look. Event, subscriber, and listener. Oh, okay. So the observer API, right? So you got here, you got is now the intersection, right? So intersection, use cases, exactly. You got now here is the use cases. So for the intersection, interception, intersection. Oh, really? Okay. Well, anyway. Intersection. So you got now is the virtualization. Damn, so you can barely see this. Lazy component analytics and dynamic UI. Okay. Lazy components analytics and lazy components analytics. Analytics. Yeah, virtualization, lazy components, analytics in dynamic UI element. Dynamic UI element. Then you got now is the this is intersection. Virtualization, lazy components, analytics, dynamic UI elements, and the other is that mutation, right? You got mutation here, where you say, hey, rich text editor and drawing tools. So rich text editors and drawing tools. As well as resize. Resize. As well as resize. Okay, this is what you got. Adaptive design. Adaptive design. Charting tools and drawing tools. Charting tools and drawing tools. But again, this is the most common example, especially if you're gonna do that. Very narrow specific to this. So this is the use case now, and it makes sense for business purpose to say, all right, when it comes to build now this complex UI patterns, we're seeing is that the Observer API allow us to cover is these specific use cases. For example, the intersections is for, well, analytics, dynamic UI elements, lazy loading components, and virtualization. Okay. Then you have now the mutations for rich text editors or drawing tools, and the other is resizing for drawing tools or for drawing tools, for SVG elements or charting tools makes a lot of sense. For example, if you want to use that for finance sectors, charting tools, that's right. And adaptive design. It makes a lot of sense.
Pattern, or in the lazy components when you need to render the component when the viewport reaches certain element, or we can also use it for analytics to see what are the parts of websites are the most visible to the user. And we can also build some dynamic UI elements. So the mutation observer is very useful for building text editors because it allows us to track the changes in the subtree in a very performant way. We can also use it for analytic pattern. So the observer API has three main types. The first one is intersection, and intersection observer is heavily used in the virtualization pattern, or in the lazy components when you need to render the component when the viewport reaches certain element, or we can also use it for analytics to see what are the parts of websites are the most visible to the user. And we can also build some dynamic UI elements. So the mutation observer is very useful for building text editors because it allows us to track the changes in the subtree in a very performant way.
The mutation. This allows us to track change in the DOM in a performant way.
It's also heavily used in drawing tools. The resize observer helps us to track the resize of the elements, and it's heavily used in adaptive design.
To track elements size in adaptive design.
Charting tools, where you have, for instance, a trading app, and you have 10 different charts, and the resize observer can be used there to update their toolbar as you resize the specific element. And it's also heavily used in drawing tools. So let's start with the intersection observer. So if we look at how we track the intersection before in vanilla JavaScript, then you would query two elements, A and B, and then you would set up the interval, for instance, 15 milliseconds, and then you would calculate the coordinates and try to see if these two elements are intersecting. So the issue of that is, imagine that you have multiple intersection observers set up on the page. This would lead to performance degradation because our callback queue will basically work only for the observers. So that's why the intersection observer was created. The idea of intersection observer is to track the intersection with the target element. So we have the first important property is the target. So basically the element that we're tracking. So the observer, the single observer, can track multiple elements on the page. So it's the observer itself is very reusable. Then we can also set up the root container that we track intersection against. So by default, it's a viewport, but you can also tell the observer a specific container that you are interested in. So one additional property is the threshold. It's basically the ratio, how much the element should be intersected before we fire the asynchronous callback. And it's also the callback is the basic asynchronous function, and we implement this function as developers. So the difference with this observer is the intersection event is tracked on the native level instead of the event level. This means that it has much better performance. On average, intersection observers perform 50 times faster than a vanilla approach. That's why it's pretty safe to use it in the production apps. So the API of intersection observer is very simple. To create the intersection observer, we just need to use its constructor. Its constructor accepts two parameters. The first one is the callback, and the second one is the configuration object. The configuration object has two main properties, which is one, root, allows us to select the container that we're tracking intersection against, and the threshold, basically the ratio of intersection. And the callback accepts two parameters. One is entries, which is the array of entries that are currently intersecting. So, and the callback is triggered in two cases. The first one when the target element intersects, and the second one when the intersection is stopped. That's why we have the special property called isIntersecting to tell us if the entry is intersecting. We have the array of, instead of having the single element in the callback, we actually have an array because we may have multiple entries being intersected in a single event. And then to observe the element, we need to call the observe function and provide the target element.
Wait a single moment.
To try the intersection.
This is the way how you do that the old way, right? Because you have to now. Okay. Okay. Exactly. So the intersection, right? This is what we have to do before. This is what we have to do before. Yeah, this is what we got to do before the intersection observer, and that makes a lot of sense because hey, I want you to now get this element and this is another element and check if they are actually now crossing, you know, and check if they actually are overlapping with each other. So if they're doing that, it means that they are intersecting. So how can we now know that? Well, we need to do that is we need to run that callback any couple milliseconds, right? And again, that's of course is not optimal. Of course, this is not optimal. Okay.
Observer was created. The idea of performance degradation, because our callback queue will basically work only for the observers.
So of course this is not optimal because of course this is not optimal because our callback queue will essentially work for the observers, which leads to performance degradation.
So that's why the intersection observer was created. The idea of intersection observer is to track the intersection with the target element. So we have the first important property is the target. So basically the element that we're tracking. So the observer, the single observer can track multiple elements on the page. So it's the observer itself is very reusable. Then we can also set up the root container that we track intersection against. So by default, it's a viewport, but you can also tell the observer a specific container that you're interested in. So one additional property is the threshold. It's basically the ratio, how much the element should be intersected before we fire the asynchronous callback. And it's also the callback is the basically asynchronous function, and we implement this function as developers. So the difference with this observer is the intersection event is tracked on the native level instead of the event level. This means that it has much better performance. On average, intersection observers perform 50 times faster than the vanilla approach. That's why it's pretty safe to use it in the production apps. So the API of intersection observer is very simple. To create the intersection observer, we just need to use its constructor. Its constructor accepts two parameters. The first one is the callback, and the second one is the configuration object. The configuration object has two main properties, which is one, root allows us to select the container that we're tracking the intersection against, and a threshold, basically the ratio of intersection. And the callback accepts two parameters. One is entries, which is the array of entries that are currently intersecting. So, and the callback is triggered in two cases. The first one when the target element intersects, and the second one when the intersection is stopped. That's why we have the special property called is intersecting to tell us if the entry is intersecting. We have the array of, instead of having the single element in the call.
Intersecting with what? With the viewport? With a top level document viewport. So it registers a callback function that execution whenever a particular element enter or exists an intersection with another element. Or the viewport. Okay. That answers the questions. That's interesting. Okay. So whenever the elements, whenever the elements intersect with another elements or the viewport, so whenever the elements intersect with each other, exactly, whenever the elements intersect with each other, exactly, so whenever the elements intersect with each other, exactly, or the viewport, a callback will be triggered. Okay, so far so good, right? Nothing fancy.
Callback, we actually have an array because we may have multiple entries being intersected in a single event. And then to observe the element, we need to call the observe function and provide the target element.
So this is the 3-step that we need to do. We need to create the instance of the observer, the intersection observer, the callback.
Okay, so this section will be very coding heavy. We're going to explore.
Okay. Three things needed when it comes to create a intersection observer, right? So we got now the instantiate the intersection object with this property. Okay. So instantiate the intersection object, all right. Create the callback, all right. And then attach the observer, and attach the Yeah, and attach the callback, or and attach the callback, and attach the callback to the observer, to the observe element. That's quite interesting. That's very, very
We're
interesting.
going to utilize the intersection observer to create a very simple version of infinite scroller, where you just load the content once you're intersecting with the bottom observer. So there's no virtualization yet here, but it's a prerequisite exercise for the virtualization part. So check out the branch name called toIntersectionObserverBegin, and if you're stuck somewhere, there is you can find the final solution.
Okay. Yep. Let's get into this. Okay. We're gonna do now the exercise here, which is wait, is this thing still here? Yep. Interesting. I don't have that loaded. No problem. Yeah, I do. Yeah, I don't want. In fact, I just want to open up a new one. For example, like this one. Yes. Password validator. Okay. Here. System design. Front end. I'm going to take a look at this. I want to open up this one. Alright, and then close this because we're not going to use this. Alright, fundamentals here, and we can say, hey, I want now to change to the intersection beginner. Oh, because we're not, of course. System design, front end, and then is here, right? And you say, all right, I want you to not change to that. You say no. Is on the fundamentals map. Okay, some fundamentals. Okay, makes sense. Makes a lot of sense. Alright. So now that we know what are the steps that we need to, as a way to exercise intersection observer, create an intersection observer instance and provide a callback to it. Okay, in the callback use mockdb next functions to get the next chunk of data. Okay, okay, okay. They get now to get the next chunk of data. Okay. Create a fragment when you chunk all of your DOM mutations. An update fragment and append fragment to the list container. But here is when we're going to create now our callback here, which is init mock that actually is now calling this. Alright, so here's when we are getting now the up bottom server. Okay, we can actually look at what's going on. We don't even need any dev server here, which is something I like to. It's something that I like to. Revealing Finder. That's right. Let's go to open up this Firefox. That's right. So right now you can, I think you can see this. There you got it. Okay, cool. And this is now the code. What is this? What part of this code is this? Oh, this is another one. No, I want to show now is the front end. There you got it. All right. Okay. But this is what we are showing here as well, right? Okay. So initially, the idea here is that when this element is intersected, I want you to now is follow this instruction here, which is like, hey, create an intersection observer instance and provide a callback to it. Let's get into this. Okay, let's go to create that. It's gonna call here the observer, intersection observer. It's gonna call this. All right, let's go to create now this instance, which is say, hey, new intersection observer, where here you need a callback. Where here you need a callback here. Let me actually take a look at the docs here. Zoom a little bit. Okay, you need to create your callback here and followed by the observer. Interesting. Exactly. And right below, right before we create is the callback, which is the callback. Right. So this is a function, right, that is going to receive now is the entries and the observer, right? So the entries and the observer. Okay. So because this observer is going to use now is the callback initially. So callback, all right, followed by the configuration object here. That's because we already get that element thanks to the document query selector all. Okay, we can now have access to the observer element, which is something that we're gonna use, but for the root. So what is the root element that I want to inspect? Is this. Okay. But it's a, hey, I don't, oh, because of course, we do this as an array, but in fact this is an object. So this is now, oh, I still do that? You got it? Okay. And followed by the threshold. So what is the minimal, okay. The minimal intersection ratio that is required to trigger the minimal intersection ratio threshold. The minimal intersection ratio to trigger is the callback, right? So now here in this callback, we need to actually take a look at the things that we're receiving here. Okay. We get is the car template and the list. Callback entry observer. You have callback. I think this is the interception observer API. There you got it. And there you go, intersection change callback. So the callback pass to the intersection observer constructor receive a list of intersection observer entries, objects, and the observer. Intersection observer entry. Okay, what this we receive is a list of this, where now this one of this entry has now interface intersection observer API describe the intersection between the target element and the root container at a specific moment of the transition. Okay, at a specific moment of the transition, this is the target element and the root container. Okay, instances of the intersection observer entry are delivered to an intersection observer callback, and it is entry parameter. Otherwise, this object can only be obtained by calling the intersection observer to take records. So you have now bounding client here, root bounds target, and time. So it return now is this. Okay, it describes what happened. I get it. It describes what happened. Describe the intersection between the target element and the root container at a specific moment of the transition. That's why we have now it's intersection ratio, route bound. Okay. So what it means is that, hey, is this element that I want you to keep track, which is the root. Is this the element that I want to keep track, which is the root? Okay. Or in this case, is this the element that I want you to keep track, which is the bottom observer element here? Is this the element that I want to keep track here? What I want to do when you intersect, because we're receiving is an entry here. If entry, okay, if entry is intersected, so whether what happened there for each of these elements here, okay, or for, because this represent, what does this callback mean? You know what I mean? It's like, what does this callback mean, man? What does this callback mean, bro? Intersection observer API. What is this callback represent? You know? It's an intersection change callback. The callback pass to the intersection observer constructor receive a list of intersection observer entries a list of intersection observer entry, objects, and the observer. So the list of entry received by the callback include one entry for each threshold crossing event. One entry for each threshold crossing event. Multiple entries can be received at a time. You can either as well the list of entries received by the callback includes one entry for each threshold. One entry for one entry for each threshold crossing event. Multiple so there are now is records or entries. Each entry describes an intersection change for one observer. Okay, an intersection change. Okay, so this entry represents is the change that happened in the threshold. Okay, for each describe an intersection change for one observer. So this is describing is as what are the what are the things that are happening when those elements what are the things that happen when those elements are intersecting, right? So as a way to actually take a look at that, okay, since this actually gets the entry, so we can do something like this. Say, hey, this is the entry, but I want to actually inspect what's going on here in this entry, right? You're gonna receive is this entry that allegedly is supposed to trigger anytime we are there, right? Because we haven't bound that element like so. Of course, it's not going to run the callback here. Exactly. We just tell is that the root observer element, but we haven't tell what is the target element. We haven't tell is what is the element that we want to observe. And that's what we're doing here. The observer dot observe and the target element, which is observer element, right? So this what it's doing is trigger that right, the observer element. So this is the root.
Branch fully component that we used before.
But the thing is that I want you to trigger is this when that intersect. Oh, unless you'd say, okay, observer observe, but we are telling it that to intersect with that element, but no, it's with the viewport, you know? If you specify this as null, as the intersection observer here. The element that is used as the viewport for checking visibility must be an ancestor of the target. Defaults to the browser viewport if not specified or if null. So here I'm going to tell, hey, I want you to do this for this. It defaults to that. But even though this must be null, because we want to trigger is on the viewport.
And we already have, we'll see that here's our bottom observer. So our goal first is to initiate the intersection observer. So let's create one instance here. Okay, so now we need to provide the callback. The callback accepts entries. And then we also need to provide
but this is never get triggered, bro. That's way interesting.
Provide the configuration. So I'll set up the threshold. I know that we have only one intersection entry, so I can destruct the array intersection to provide the configuration.
Exactly.
So I'll set up the threshold of 0.2, and I'm okay to use the viewport as the intersection root. So now we need to handle.
So only this, because I want to use the viewport as the intersection root. Okay. But that's quite interesting.
Our entry, since I know that we have only one intersection entry, so I can destruct the array and have single entry here, so I don't need to loop for that. So now we can check if the entry is intersecting.
Okay, it's because it represents this. You know, it represents this. Because we only have one element that is intersecting with that.
The next step.
Because we don't have multiple elements intersecting with that.
Is to fetch a new data. So
the thing here is that it's like this only gonna get triggered okay, so if the entry is intersecting, but it's not even triggering, is that? You know, it's a console log. Okay. You know, but to me it's quite interesting because it's not triggering, is that?
So let's fetch a new data using our MockDB. So let's convert this callback to a synchronous one, and then use await. on our DB, and then we have a
convert
method
our
called getPage.
callback to a
The
synchronous
getPage
mode.
accepts the pointer, which is the page number. So let's create one variable that will start with a 0, and then every time we execute the callback, we're going to increase it by 1. Okay, now we have our data. So we need to convert this data to HTML elements. So we can create a new fragment to accumulate all the DOM mutations we're planning to do. So we create a new document fragment. And now we're going to loop for the data.
So after we create this, okay. So after you create this, so after you get the data, which is something that is not relevant for this because it's very something specific to the db.get, where the f is this, db.initMock data get page. Okay, it's returning that get page. Okay, so you say get page, right? Where here you're gonna pass is now anytime you want this to pass through that. I want you to increment now is the page. Okay, and for that I want you to convert this callback into an asynchronous one, right? By saying async for that. This is not at this level, is here. Okay, and then now we need to convert that data into the question is what is the shape of that data? Here we go. It's a promise of any you gotta hate it of the data. Okay, what you have now is this data that is an array where you slice that, and that is now an entry here initMock data. And anytime you now run this, what you're gonna do is to say pointer is less than 0 is greater than data.length. I want you to now is or return is an empty one if this condition is true, or index this. Okay, because this data here is actually creating is based on the data.length that you have right now divided by the page. It will give you now some of these elements. And okay, array.from is saying this will be the length here, and this will be now is the this will be the elements that I want you to create. Data.slice is one page and page plus page. What is page? Is a parameter that you're passing here, like this. Okay, followed by the sample. Sample is something that you're also passing here. initMock data, exactly. And then you're going to now from the entries construct an object and return now a collection of that. Okay, because this is what is happening initially. But you have now the entry of this and with v, which means what in the f is v is data that we're getting from the entries of the key and value. Okay, so you are now building is this particular object with title and body and that kind of thing. So not only that, you need also is a way to create this document fragment, which is fragment, right? Why is that? Because this document fragment where we want to hold this on memory, okay, Will you take me to there? To MDM docs, bro? It's like new document fragment. Okay. Will you take me to there? No? Doesn't matter. It's now allowing me to create this HTML representations. Yeah, that's right. These HTML representations here, document fragments, where now first element child. Okay. Where here is when I'm going to now build is this element, right? So by saying is now document fragment, and I'm going to now build all the elements that this particular fragment has. Okay. And then append that, which is, hey, I'm going to now create that element here.
And we are going to create a card using our create card function. And then we are going to pass datum title
and the body
and datum body. So now we created our card element. We want to add this card element to our fragment.
Exactly.
So we use fragment append child card. We updated our.
So what we're doing is creating is now all of this card for us and append it to the
fragment. So we now accumulate all the DOM updates within this in-memory object.
So we can accumulate all of the DOM updates is to the element in memory, not on the real DOM.
And once we finished updating the fragment,
we need to also is updating is the fragment, but to the DOM.
We can finally append the element to our list, which we already queried. So let's use list, append child.
Exactly. So what you're doing here is to say, hey, because here, after we create that, I want you to now iterate through all of this. Oh my god, it's a lot of boilerplate going on. But I want you to now iterate through the title. Where we are going to iterate, I'm going to iterate is to the data that we're getting here for, okay, so the data of the datum that we're gonna have here, which it must be an iterable, of course, right? So this iterable thing is something that you are now going to say, hey, we're gonna receive this or data as entry, like key and value, like title and body. Okay, we're gonna create that based on the data that we're passing initially here in init-mock database. But here is what we're going to create now is all of our card. We say, hey, counts card, right? We're gonna call that function called create card. What we're gonna pass is the datum dot title and datum dot title and datum dot body. Okay, so with this card create card elements, that kind of thing, after you do that, I want you to now append that to the fragment. So fragment has now this append methods or append child here, and I want you to append is the card as expected. So fragment is a document fragment, and the document fragment what it returns is an element. What is the structure that you return? You know. Is to create one or assembly a DOM subtree. But exactly what you are creating, what you are returning. That's my question, right? What do you return? The document fragment. Return a value of new document fragment objects. And this document fragment interface represents a minimal document element that has no parent. It is used as a lightweight version of document. So this document, okay, they extend from the node. Okay. So because they extend from the node and it is property, this base class, it makes a lot of sense that we can have access to the append child. Alright. So not only that, after that we want is to append that fragment after the for loop is done. We want to append that fragment to the list element by saying list, which is something that we use when we query that data here. Document query selector all, say list. This is now returning is a node. This query selector all return is a node element, node list. So the query selector, the query selector all returns now is, yeah, it's okay. So the query selector all return is a node list. Okay, makes a lot of sense. Where now this node list, of course, have access to this. This is the base class here. Okay, so it means that we can now append elements to the DOM. Append child, which means that I'm going to append this fragment as it is. And there's something here. I think there's something missing here, because if I reload this, it's not triggering that because it's not recognizing. I'm not appending that to the right object. Why is that? Okay, observer.observe, right? It's like not only that it's like I am appending that properly, but the problem is that I am observing is an element. I create my observer here that the viewport will be now the viewport will act now as the intersection for this particular element. All right. So
fragment. So instead of having, for instance, 10 operations, we now just have one, and now the intersection observer is ready. We need to observe the element that we are trying to observe. So let's use observe, and provide our element, which is already here, observer element.
Observer element, exactly.
So, and if we run this in the browser, we'll see that.
In my case, I don't know why this doesn't work.
Which is already here, observer element.
It's because this is lowercase. We're actually using this as a lowercase, which is great. And the only thing that we are changing here is saying, hey, you know what? I'm running this is not as a part of entries. You know, I'm running is this, but as an entry here. which means that instead of having this, okay, we're gonna have this one entry. All right. And of course we need to is and of course we need to indicate that this will be a sync. Okay. However, when we load this, it's not loading. That's to me is the most quite fucked up things of all of this. I'm not using that properly. New interception observer. The only subtle different thing here is that I'm not going to. Is that instead of actually calling the callback, now what I'm doing is this. That's the only thing that changed here. But even though this doesn't work as expected, new intersection observer.
So, and oh, it's actually so now we have our card, the intersection observer created.
That is quite interesting. Is this actually work? That's quite interesting. That's quite interesting. Is this not even work here? What about in Chrome, bro? Holy moly. It's not even working here. Oh, but this is some course policy. Okay. Okay, makes a lot of sense. Okay. Okay, but this is the browser scary about this. It's like, no, what are you doing? What are you doing? Okay, this is the browser scare. Okay, loading files locally has been historically treated as the same origin. That means that if a file and its all resource could be loaded from a local directory or subdirectory during testing without triggering an error. As having opaque origins. You gotta be fucking kidding me, man. So I need to set up a local development for this? Fuck.
Case. So now we have our cards.
Show course errors in console. Group similar message in console. Eager evaluation. Autocomplete from history. Treat code evaluation as user actions. Yes, bro.
Perfectly rendered, and when we go down, we render more data. And that's it for.
Wait a single moment, bro. Because I face, there's always issues along the way. And the configuration here.
Our second exercise. So let's overview the solution. So we set up the intersection observer, created the fragment, and
no, the problem with this is that it's not loading. Now what happened here is this import. Type model. Yeah, because that's quite interesting. Yeah, but I don't want. Is there any alternative to prevent that? Do I read? Oh my fucking god. You gotta be fucking kidding me, man. No, 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 no. Nah, fuck that. Fuck that, bro. Fuck that. Paste that code there. No, goddamn. I don't. Oh, is it? Oh, I get it. I get it. Okay. Okay, now it parsed that properly. It said, hey, I don't recognize these things called page. Yeah, because in fact this must be is a cons. Hey, you know what? Okay. You win this, bro. You win this, bro. You win this, bro. You win this, bro. I want to spin up a dev server here.
Now the intersecting our engine. So here's our bottom. backups accepts entries, created the fragment, and appended all the new card elements to the fragment.
Okay. It's pathetic. Jesus. Ah, because it's npm star. Make sure to save this. That's fucking disgusting, man. It's fucking disgusting. Yeah, we solved that. Not with the class and all that kind of stuff. But yeah, it's like that's fucking disgusting, man. It's like that. It's actually loading that. But I need a freaking French toast service to run this. That's definitely not what I wanted to do. Okay, I get it. So I will need is a. So I will need a dev. Oh, okay. So I will need is the web containers or sort of that. So I will need to run is. Holy moly, bro. Okay, so browsers are scared of that you execute JavaScript code. Hey, you're gonna execute JavaScript code? I'm scared of what you're gonna do. I'm scared, and I am deeply scared about what you can do, what you are capable of. So no. I don't feel secure. I don't feel safe you doing that. You know? I don't feel safe you doing that. And I get it. Yeah, they should have to be a. Okay. Oh my god. Okay. Okay. So I need a server to run this. But okay. That's interesting. That's very, 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 very interesting. method, and then it returns you but once. But this is the way of how you can at least basically can actually generate that format. So okay, all right, okay, no problem, no problem, no problemo, bro, no problem. Yeah, no problem. That'll be all for this video. Take care. Bye bye.